Hi, I'm Nathan Knight, an embedded applications engineer from Altera Corporation. FPGAs are becoming more and more common in embedded design. If you haven't already, you're likely to see one in a future project. Fortunately, the software development flow for an FPGA-based processor is similar to what you're probably used to with an off-the-shelf processor. Today, I'm going to show you how easy it is to develop software for an FPGA-based embedded system. I'm going to demonstrate this using the NEOS 2 Embedded Evaluation Kit. NEOS 2 is a configurable 32-bit processor. Because it's configurable, you can select the exact set of CPUs, peripherals, and interfaces that you need for your application. So let's get started. First, we'll turn on the NEOS 2 Embedded Evaluation Kit. This kit is perfect for developers that are new to FPGAs. The kit includes hardware development tools, software development tools, design examples, tutorials, and all the documentation you'll need to get started with your first design. Everything is in the box. So the first thing you'll see when the kit powers up is the application selector. This displays all the applications that are preloaded on the SD card. In a moment, we'll show you how to create your own applications and add them to this list. To quickly demonstrate the processing power of NEOS 2 plus hardware accelerators, let's load up the Mandelbrot demo. While we're doing that, I'll show you another unique capability of this kit, which is how the applications are actually loaded. First, let's look at the system. The board contains an FPGA with a NEOS 2 processor, an SD memory card, and a flash memory device. To reconfigure, first the processor copies the hardware image from the SD card to the flash memory device. Next, it does the same thing with the software image. Then, the processor instructs the FPGA to reconfigure itself from the flash memory. The new configuration, which contains a new NEOS 2 processor, then boots from the flash memory device. The application then starts and begins running. Now that the Mandelbrot demo is loaded, let's take a look. This demo calculates the Mandelbrot fractal using two methods. First, using hardware accelerators. Normally, to achieve this kind of performance, you'd need a processor that is much higher speed. But by utilizing hardware accelerators, NEOS 2 can achieve this performance running at only 80 MHz. The hardware accelerators in this particular example were created by the Altera NEOS 2 C2H compiler, which compiles ANSI C code into hardware accelerators. As a comparison, this is the performance you can expect to see when the hardware accelerators are removed, which, as you can see, is much slower. Now I'll show you how to build your own application. From a software development flow, it's very similar to what you're probably already used to. First, your hardware engineer hands off a file that contains a description of your NEOS 2 system. Next, the NEOS 2 software development tools automatically generate a BSP from this input. If your hardware design changes, you only need to generate a new BSP. You do not need to change your application software. The NEOS 2 tools also make it easy to program your design to Flash by providing a Flash programmer utility. This utility also inserts a boot copier that boots your system from Flash and copies the software to RAM. We provide examples that show you this entire flow. For this demonstration, we'll start here. A hardware design has been created for us, and we've generated a BSP. Let's take a look at the C code. As you can see, this is typical C code that we're building. Now I could build this project right from the NEOS 2 IDE, but for this demo, I'm going to build it from the command line. To build the project from the command line, we just type make. Now we can see, after finishing the build, that we have an ELF file, which is the executable file that we'll be downloading to the board. Now let's load that software file onto the development board. This can be done a couple of ways. The way we'll do it is using a USB cable. First, we configure the FPGA with our hardware design. Next, we download the software application to RAM and run it. And now we can see the spinning cube application running on the board. At this point, you can also copy the hardware and software files to an SD card, which will allow your application to appear in the application selector the next time you power up the board. So now you've seen some of the capabilities of the NEOS 2 Embedded Evaluation Kit, how the software development flow works, and how to build your own application.